Hello and welcome back, everyone. I hope you have your short coffee break. Next up is a very exciting session by Peter Koen and Paul Latzelsperger about Dataspaces. So without any further ado, the stage is yours.
Hi, welcome everyone. So a very unusual topic for somebody from Microsoft to present, because today we are talking about an open source project from the Eclipse Foundation that is helping us to build multi-cloud data spaces. And don't worry if you've never heard about what the data space is. That's a fairly new topic and a new business and architecture pattern that Paul and I will show you some around today, with some basics of what a data space is and how early code fragments of the Eclipse Dataspace connector look like. So the motivation for creating data spaces is something that was created more or less in politics, at least with the term data spaces, because the European politics has realized that they're struggling and falling behind in the international arena of cloud computing and generating value from data. And so at the level of the European Union, they have proclaimed projects to help European companies to generate more value out of their data and to protect their data from malicious players in the international fields. And that kind of led to the creation of a project called GAIAX that I will talk a bit more about a bit later. And it started the term Dataspaces, or in the German version, Datenräume. And this concept of data spaces is something that is not just a political invention, but something that we at Microsoft have seen emerging as a concept in the work with our customers. And so when we talk to customers about data changing, the old way of doing it was first just bilateral data exchanges, two customers getting together, agreeing on a contract to share data between each other, and which is usually a very cumbersome way of doing it, because you have to negotiate the trust envelope, the contracts, the meaning of the data, and so high value, but also high amount of work involved. That evolved kind of to a closed group data exchange, multiple companies getting together, defining business meaning of data, defining a joint trust envelope, and sharing data amongst each other. And now what we're seeing is the evolution of that, what we would call a data space, which is a decentralized, dynamic consortium of participants that everyone has data to offer. Everybody can consume data. There can be players in there that offer algorithms that will work on these data. And together there is a trust envelope that basically helps ease the transition from one company to the other, and that helps very quickly and dynamically build those one-on-one relationships, but also keeps the standard open so that participants outside of the data space can interact with this data space in a controlled manner. And once you have these data spaces and you put them together, you'll see that companies will be part of multiple data space ecosystems. So for example, if you're an automotive supplier, you could be part of a smart city data space that enables you to provide connected car services, like finding the nearest parking spot, finding the nearest EV charging station. But you could also be part of a data space that is on the supply chain side of your business. So, for example, a data space that allows you tracking the materials in the car that you have built. What kind of materials are in it? What value would they have for a recycler? How much embedded CO2 and energy is in each part that you build? And so these data spaces have usually as a foundation a common business need, a common regulatory need, common compliance and certification need, and they allow these companies to manage how they participate in these data ecosystems. So when the European Union realized that this is what European companies will need to generate more value from their data and to increase trust in their data sharing, they have started the GAIAX, European Association for Data and Cloud. And that is a not-for-profit and non-government organization that is supposed to build the rule book of how to build those federations that will allow you to have a common root of trust, a common trust framework, common technical standards, common architectures to enable data spaces. On the other side, GAIAX is also building standards for the infrastructure part, but today we only want to talk about the data spaces. So contrary to what you read in the media, GAIAX is not a new company like an Airbus of the cloud industry, building data centers, laying new cables in the ground. It is really focused at what are the rules that should govern the use, consumption, and sharing of services, and with that also the use of data inside of the European Union and its industrial companies. And specifically for the data spaces, another organization has been founded, the International Dataspaces Association. This is also a non-for-profit organization, and their goal is to foster, to create the standards of data spaces from a technical perspective, but also from a certification and standardization process. And the Eclipse Dataspace connector is a member of this organization, and it follows the standards that this organization has produced so far. So this is not a product that is created by one single company, but it is an effort to create new ecosystems for the exchange of data. So you can think of the Eclipse Dataspace connector of what Kubernetes did for compute, the Eclipse Dataspace connector is doing for the world of data exchanges. It creates common standards in an open source project for everybody to use and to benefit through easier and more value generation in the exchange of data. So that basically to explain that in more detail, there is a set of basic services in such an Eclipse Dataspace connector. It helps you by providing cataloging services where you can discover data sources from others as well as publish your data sources to others. And it helps you managing policies that would allow you to control what is allowed to happen with the data once you share it with others, which also controls who can access your data, under what conditions would you copy data to another location. It has services to log and monitor how those data transactions are taking place. More on that when we get to the architecture. So the value of a data space is on top of the peer-to-peer data exchanges that are happening. You basically have a common framework of how do you create trust, how do you discover data, and how do you prove your identity within this environment so that you can enable ad hoc scenarios as well as scenarios that are backed by real-life contracts behind it. And so let's have a look at the Eclipse Dataspace connector, how this project now implements these concepts that I've just explained on a very theoretical level. So the EDC, for short, is an official Eclipse Foundation project. So the reason for that is that it follows the Eclipse governance standards. It is very clear who can contribute to the project, who is the committer on the project, which guidelines do we follow in creating code contribution and making decisions on the roadmap. And all source code contributed to the EDC has to be contributed under an Apache 2.0 license. So it is truly an open source project, not controlled by any of the companies involved in writing and committing code to it. So as of today, and Paul, sorry if I promised too much, we have a basic engine running that can do data transfers, which Paul will demo in a bit. It including a state machine for data assets and policy contracts, and the negotiation of a data contract based on its policies. And there are some shared service interfaces that will allow you to extend the product. So with that, let's move on to some of the features that it provides. So the EDC itself is a platform. It is not a product. So it is at the simplest, you could look at it as a collection of libraries and code frameworks put together that allow you to then instantiate a data space server that would act as a gateway into a data space. So similar how you have a proxy server for your HTTP traffic, how you have a firewall that connects you to the outside world and make sure that only the stuff that is allowed to comes through. You have an EDC now to control your access into the world of a data space. So it can control what verifiable credentials need to be true to participate in the data space and what you are offering to the data space. The architecture itself is built in a way that it separates a control plane that executes the identity management, catalog management, and policy management from the actual data transfer plane. Because the data transfer plane is going to be highly dependent on the technologies in which you actually have your data. That could be your on-premises mainframe, your Azure blob storage, your AWS S3 storage, or just some local storage on a Raspberry Pi. All those technologies have to be supported, and because all of them could potentially be data sources for a data space. And so therefore, the EDC builds a highly pluggable model of extensions that allow the developers to build their custom extension for their storage technology or for their policy technology, as you will see later. And the system, of course, is built enterprise ready by allowing to scale up as well as scale out, and by having asynchronous processes that make this thing really highly available and resistant to disasters, and really flexible in how you access multiple data spaces. And of course, given how valuable data is from the very first day when this project started, ongoing security analysis and threat modeling on the architecture and the code has been done to ensure that the architecture here is built with security in mind, and ensuring that data cannot get accidentally lost in the data space. So in a bit more detail, I already talked about it. There's this control plane. The control plane basically takes care of identifying to the data space who you are, verifying identities of other players in the data space. It oversees the policy enforcement, the contract negotiation, and then once a contract has been negotiated and accepted, it manages the provisioning and the execution of a data plane item. And the data plane is then responsible for actually transferring the data between two players. And that allows a separation of the data transfer technology and the technology that's responsible for managing policies. And within this control plane as well as data plane, you have this engine that runs the policies. And the policy on data could be something like, I only send you the data if you prove that your storage is located in Austria, because I have data that legally can only be stored in Austria. Or I have data that I'm willing to share with you for AI training, but you're not allowed to use the data in your supply chain application. Or another policy could be that the data needs to be stored in a cloud environment that has a C5 certification. Or the data needs to be anonymized before it is going to be shared with other players and third parties in the data supply chain. So these are the kind of policies that the system is enforcing on the data. And you'll see in a minute how that looks like in the project and how it actually works. So just really briefly, I already talked about it. The design is built around a core module system that has Java service provider interfaces, and then the policy service, the data catalog, the identity engine. They're basically built as extensions where you can then provide your own code and your own implementation if you want to, or you just go with the base set of extensions that the EDC today provides. And we've already seen new projects in open source coming up in parallel that then focus on building specific extensions to the EDC. So the example that I've just mentioned here, I talked about the catalog service, but another example of such an extension system could be a member registry where you can register and discover other members of the data space, or the contract negotiation and data sharing engine. And before I bore you with too many of those high-level overview slides, let's switch over to Paul, our lead developer in the Eclipse Dataspace connector, to give you a quick round around the code.
Hi, guys. Oh, that's interesting. Let me switch over to my editor here. So when you check out the EDC, let me just call it EDC because it's so cumbersome to say Eclipse Dataspace connector, so it's the EDC. If you check this out and you're using VS Code, as I've been not instructed to do by Microsoft, so then you see a couple of things here. Let's just walk through, first of all, the top-level directory structure, because that can give you an orientation on how the thing is built. So what we will walk through is a couple of things. I'm going to show you the basic structure of the repository. I'm also going to show you and talk a bit about the state machines that the EDC incorporates. And then if we have time, we can go into a bit more detail. We will also see a short live demo where we actually transfer data from one location to another, and how that looks like and what steps are involved to do that. But let's dive right into it, right? So when you check this out, you have a couple of things here. You have the ever-present commons folder, for example, which is where all the utils classes go. No project is really complete without at least a couple of util classes. We have a few of those. We have the core folder here, which contains really the heart and the guts of the entire thing. So what we have is, for example, we have for bootstrapping, we have the boot directory that contains classes like, for example, a monitor, which is our notion of a logger. It contains stuff like the extension loader. So everything that is pluggable, that's a plugin, in our lingo is an extension. So that's in there. By the way, that uses the Java service locator pattern. For those of you who are familiar with it, it's sort of similar to how Spring does things. Then we have, for example, the contract focused classes like models and state machines and stuff like this. Micrometer, which is pretty brand new. We're using this for tracing and analysis, and profiling. The policy engine is stored in policy, and the transfer subsystem is stored in the transfer folder. Then as a next set of modules, Java modules, we have data protocols, which as of now, since we're using IDS communications, so if two connectors want to talk to each other, they do so via a standardized protocol, which is IDS. So everything that pertains to IDS, like all the dispatchers, which uses multipart, all the core classes, serializers, transformers, all that good stuff is in that folder. So if you want to dive into that world, be my guest and do so in the data protocols folder. Of course, we have a bit of documentation, and just to get out ahead of it, documentation now isn't perfect. That's certainly an area we need to improve. So if any one of you is keen on writing and wants to contribute at this point, shameless plug, please do so. Come along and help us. We desperately need your help there. And then we have a couple of other things like resources, like an open API spec. We have a couple of samples, most of which are also available as a short video walkthrough on YouTube. I think Peter is going to provide a link later. So there is essentially a sample for everything that's going on in the EDC. So that should be your landing point, actually. So if you dive into the EDC, go through the samples, read the onboarding, watch the YouTube channels, the YouTube videos on the channel, and you should be at least somewhat knowledgeable. Then we have SPI. SPI, as Peter mentioned, is the service provider interface. So that contains all the general classes, common classes, service provider interfaces. So for example, if you wanted to implement your own contract negotiation engine, which we advise against, but if you're hell-bent on doing so, you can do so by just importing the contract SPI and implementing everything that's in there. Same thing for transfer, for example. Or if you wanted to, I don't know, exchange Jetty for your preferred embedded web server, you can do so by implementing the web SPI. So the keen reader might have noticed that I have gracefully stepped over the extensions directory there, because it's actually the fattest one. So everything that is extensible or that is intended to be extensible, that goes in there. For example, we have modules for storing stuff in AWS S3 buckets. We have stuff for storing data in Azure Blob Storage. We can use Cosmos DB as a data backend. We have an Azure Event Grid backplane implemented. We have for data loading, we have quite a bit of code there. We have the entire HTTP subsystem, like for example, Jersey and Jetty. That's in the HTTP extension. So we are using Jersey and Jetty as our drivers to expose REST interfaces. IAM is identification and authentication. So everything that's OAuth or even WebDid. By the way, WebDid is another interesting topic. So that goes into IAM, like decentralized identity. Then there is the in-memory directory. That's actually an important one, because by default, what we do when we implement something, I don't know, maybe a backing store for some service that needs persistent storage, then what we do as a first step is we provide a default implementation which is in memory. In most cases, that's just a Java map or a Java list, simply because that that guarantees a low barrier of entry, and it doesn't require the distribution of access keys or shared access signatures to some cloud resources. So by default, there is the in-memory implementation. We have Ion, which is a Microsoft technology, which is an overlay network over Bitcoin, or the Bitcoin blockchain that is used, or is one option to use decentralized identity. We have a bit of logging there, like JDK loggers. Then we have all the policy enforcement. IDS policy goes in there. We have an SQL extension, like if you wanted to use not Cosmos DB and not in memory, but SQL, you can do so. Bit of transaction related stuff, like for example, so that means database transactions like Atomicos or local database transactions. That's actually a really detailed thing that I don't think we need to walk through now, but if you wanted to take a look, you can do so. And that's actually, I think, most of it, which is interesting. So everything that is extensible should be implemented as an extension. And the way to do that, maybe let's pick one at random. For example, say we wanted to implement an asset index based on Cosmos DB, such as we have. What is required in order to do that is using the Java Service Locator pattern. You need to create a special file which follows Java Service Loader guidelines. The name needs to be identical to the interface it implements, and it needs to contain just one line, or for every implementor that's available, it needs to contain one line. What this essentially means is if this module, asset index-cosmos, is on the class path, it will automatically load the Cosmos asset index extension and provide it as an implementor for this interface. That's what that does. And our entire system is built around that, because what that guarantees, or what that grants us, is to simply, by defining what modules are on the class path, it defines how the application actually looks like. Meaning, say you wanted to swap out the Cosmos asset index extension for another asset index, like an SQL-based one, what you need to do in your build file, remove the asset index Cosmos dependency and replace it with an asset index-SQL dependency. And that's it. No switch case statements need to be written. No reflection needs to happen. That's all done out of the box by the EDC's very core, which is the Bootstrap. So now that we have a course overview over what classes there are, let me just take a step back and ask if there are any questions. I'm going to switch over to the other screen now. Maybe this comes up with the infinity screen again. Okay, no questions so far, then let's just continue. I mentioned before, there is several different things that are really important and really central to the entire Eclipse Dataspace connector framework. So we have So everything that we do is asynchronous, meaning you cannot expect the other party to be there or to respond in a finite amount of time. Like, say you wanted to negotiate a contract for some data asset, then you need to be prepared to receive every answer in an asynchronous way. That's because answers can take a long time. So what usually happens before we can do a data transfer is two things. First of all, we have the contract negotiation. So every asset, and when we say asset, we mean essentially a data item, like, for example, a file or a stream or I don't know, a log or something. So every data asset that can be shared is what we call an asset. Then, so what needs to happen is, if you have your connector and you go to the other connector, which in our lingo is the provider, your connector basically has to say, hey, I'm connector, I don't know, I'm Paul's connector, and I want that data asset. And in doing so, in the background, what's happening is a contract negotiation. Like, my connector goes to the other one and says, hey, I want that data item. I can guarantee that policy that you want enforced, I can fulfill that. And once the negotiation is done, which at the moment is automatic, as a next step, it switches over to the transfer state machine, is essentially starting the data transfer. There's a couple of things that need to happen during a data transfer. So a data transfer can be initiated. On both sides, it can be necessary to provision resources. Just imagine I want a certain file, but I want it to be put in my S3 bucket or in my storage account, for example. Then I can provide temporary credentials to that storage account to the other connector, essentially telling him, if you give me that data, please put it into that bucket or into that storage account. So, and it's possible that I want to provision or I want to create those resources just for the purpose of the data transfer, meaning they need to be provisioned. So that's another step during this transfer, is the provisioning. Like, on both ends, it could be necessary to provision resources. So when the client or the consumer, which is me, needs to provision something, it's almost always the data destination. When the provider, that's the one that owns the data, needs to provision something, it could be, for example, that he needs to, I don't know, prune a log file or prepare data which is in raw format, but it needs to be converted into a special data format or something. So provisioning can happen on both parts of the equation. So that's a very important step. And so let's take a look at that. The route where we actually need to enter the entire thing is the so-called transfer process manager, or the implementation of that. You can walk through the entire thing. Just wraps that so that we can take a closer look. The transfer process manager, that essentially is an infinite loop that runs and that ticks over different states. Like, there can be the initial state for a transfer process. It can be the initial state is, by the way, that one that will in the end trigger the provisioning. We'll talk about provisioning in a moment. It can be in the provision state, which means both ends, both communication participants have provisioned the resource and the data transfer can happen. Then there is the requested, or more specifically, the requested ACK state. That's where when both parts report, yeah, we're ready for the data transfer. Then the data transfer can be in progress, meaning data is being shuffled from one side to the other. And then after some time, both parties can have a request deprovisioning the resources, meaning, I don't know, maybe I have taken the data out of my bucket or my storage account, so I can deprovision stuff. So I can tell my connector, yeah, you're good to deprovision it, I don't need it anymore, let's not incur cost. And that's what that's doing. So let's step through it. What we also have, so in the initial state, it will try to determine whether it's necessary to provision something, which is done by the provision manager. We just collapse that again. So the provision manager actually has two important methods. The first one is just to register provisioners. So you can provision something for a transfer process, or you can deprovision something for a transfer process. And what's behind that is every transfer process, the data model for every transfer process allows for the definition of so-called resources. For example, to remain in the analogy, or in my example, when I want to provision an S3 bucket, I need to define a resource which describes my S3 bucket. That, for example, would be the S3 bucket resource definition. So that has a couple of properties. It has a region and it has a bucket name. And in doing so, I have completely and fully defined my bucket, which I can then hand over to the provision manager and in turn to the provisioner, who will then go to the Amazon S3 SDK and to the Amazon API and provision that bucket for me. Analogously, there is an object storage resource, which would be the same thing on Microsoft side. The difference here is that it actually contains different properties, because as you saw, the S3 bucket resource definition had a bucket ID and a region, whereas the Azure storage, the object storage resource, only has a container name and an account name. So when the provision manager then eventually returns from the provision steps, which it does using a completable future, it returns back out to the transfer process manager, who then ticks over to the provision state, ticks over to the requested state, sends out a couple of different messages so that both participants, they know what's going on. And then in the in-progress state, this is where we hand over to the actual data transfer subsystem. This is what Peter previously described as the data plane. So let's see. There is a couple of checks, because a consumer cannot actually transfer something, the transfer always has to take place on the provider side, because the provider is the one that actually possesses the data. Manage resources, that's an important flag, because that determines whether the resources are provisioned by the connector or it reuses some already existing resources. So the one we are looking at here, that's the one we want. So in this method, we're actually, as I mentioned, we're processing all the transfer processes which are in progress state. Just as a side note, all the transfer processes are stored in a backing storage. So whenever the EDC crash due to some unforeseen reason or an implementation error and comes back up again, it all should be able to continue just where it left off. We've taken quite a bit of measures to ensure that it works in a clustered environment. So should the EDC crash during a data transfer, it should be able to just come up again and resume the transfer. Right, so this is that was a pretty high-level view of the transfer process manager.
So, Paul, given that we don't have the entire day for us, unfortunately, maybe a quick peek at the policies.
Sure.
And maybe also explain how the two sides interact then on policies. If we tell the receiver that they have to delete the data after 7 days, how does that work here?
As a first starter, so the policy engine at this time is in a very, very basic state. Let me just open the class so you can have something to look at. Right. So a policy has a couple of properties. It has permissions, it has prohibitions, and it has obligations. So permissions is something that you are allowed to do with it. That's formulated in a certain language, which in our case is probably going to be ODRL. Then you have prohibitions, which you cannot do with the data, meaning, for example, you cannot, I don't know, use it outside of a certain geographic area. And then there is obligations, which the policy forces you to kind of fulfill. So the policy in eventuality is going to be a hierarchical set of rules which describes what you can do with it. And one thing that we have implemented at this time is, for example, that a policy describes where the data needs to be located, a geographical policy. So let's maybe open another class here, which is a contract offer, because there it becomes transparent how this works. So a contract offer is something, A contract offer is something that, as a name says, when I want to transfer an asset, this is what I get sent back by the owner of the asset. So I basically, I receive this structure. So this means it contains an asset, which data item that is, and it contains a policy, meaning this is whatever I need to fulfill before I can actually transfer that asset. And for example, if this policy contains a region clause, then I, on my side, need to guarantee that the data is transferred into any kind of storage in that region. Is that somewhat understandable so far? Are there any questions? If there are, I'm going to switch over to my other screen again. Hit the screen. I haven't seen, well, let me just continue. Right. So then there is this other class, which is called the policy engine. And the policy engine, if you look at the code, it sparsely commented, it evaluates policies, meaning that for every participant agent, which is an internal representation of a connector or a company owning a connector, that's going to evaluate whether that policy for one certain participant agent can actually be fulfilled. There are a couple of other functions, like you can register a policy function, which would be a lambda, which you could apply then to a policy. But the essentially important thing is this policy evaluation thing here. Let me just open up the implementation. So it gets the policy context for that participant agent. It tries to evaluate all the okay. The way this works is it uses, I think, the visitor pattern. It tries to validate all the rules that the policy contains against a certain participant agent. There is pre-validations. Then it validates all the rule functions, which what we saw before. You could register those functions in the policy engine. It evaluates all the constraint functions, which would be another way of registering your lambdas. And then in the end, if the result is still valid, it has a couple of post validators. And if everything goes well, then it returns out back with a result message. And this is, for example, done during the contract negotiation. So during the contract negotiation, let's just open up that class here. That's the place where policy evaluation happens. This interface is actually spread out into two sub-interfaces, because there is one for the provider side, and then there is one for the consumer side. Let's just open up, for example, the consumer side for 1 second. So that has a method on it to initiate the transfer. So whenever a contract offer request comes in, meaning, hey, I want to have a contract, I want to negotiate a contract for a specific asset, this is done in the form of a contract offer request. And that, by defining which asset I want, it also implies the policy that needs to be applied for it. So theoretically, it would be possible, and that's actually one thing on our roadmap, for this negotiation state machine to have a way where humans can intercept, meaning someone prints out a sheet, goes to their boss and gets a signature, and then goes back to his computer and clicks a button, and then the negotiation continues. That would be, for example, one way where how policies could be, or that would be a way for a policy to require an actual signature for a human, and that's how that would be reflected in the contract negotiation. Okay, so how are we on time?
Thank you, Paul. I think we are reaching our mandatory end, so let's just switch back to the slides, and yeah, while we open the floor for questions, 2 slides with all the links where you can participate in the feature discussions, help with the code, see the project backlog, or just join the mailing lists or the before mentioned YouTube channel. You don't have to write down those wonderfully short links. The slides will be made available afterwards. And with that, if you have any questions, feel free to ask.
Okay, then let's see if any questions are coming in. Otherwise, thank you very much for that session. I will post the links to the slides that you mentioned afterwards. And since I don't see anything coming in, thank you very much. And for the other ones, see you at the top of the hour for a session about Azure Container Apps.
Maybe also one last comment. The YouTube channel doesn't feature just the high-level explanations. It also has a 1-hour-long code walkthrough from Paul and a recording of a 3-hour developer tutorial session. So if you really want to get into the project, I think the YouTube channel is your easiest starting point.
And don't be afraid to hit us up on discussions. There is really a very active community and people will respond to you.
Thank you, everyone.
Thank you.
Enjoy the rest of the conference. Bye-bye.